Okay, good morning, everyone. This morning's session 3M. If you can remember to do your feedback at the end, that will be appreciated. We do really use it. I will drop a link for the feedback into the chat. You will all be muted throughout the session. So again, if you have any questions, please put them in the chat and we will either deal with them during the session or at the end. I think that's all the admin out of the way. So I will now hand you over to Jussi, Bernard Jestema, to talk about the terrible pronunciation, I know, sorry, for some Z system automation hybrid cloud usage scenarios. Over to you.
Okay, thank you, Anna. Yeah, good morning, everybody. And as Anna already introduced me, my name is Bernd Jostmeier, but most people refer me to Josie. That's especially for English-speaking people much easier to pronounce. So yeah, I'm from the IBM lab in Germany, and particularly I'm a software developer and architect for system automation, Z system automation. And in this role, I want to talk to you about today about some scenarios how to use system automation in hybrid cloud usage in hybrid cloud environments, and what we did in the past also and still doing in order to enable especially system automation for that hybrid cloud world. So first, let me start with a little bit of background and just very short. So first I want to talk about what is that hybrid cloud about. So it is like nowadays the idea to have multiple different environments, maybe like traditionally on-prem virtualized, but also then later private cloud, public cloud, and things like that. And hybrid cloud integrates all them together. So you as customer have the freedom of choice to say where you want to host pieces, components of your applications, whether it be on your own systems on-prem, still managed in the traditional way, or you might have even a private cloud set up in your company, or you're sharing with others on a rental base resources from public cloud and bring them together. All those components have to be managed somehow because they all play a role in the in the composition of the components of your applications. So the picture is here now that you, no matter where you are using computing resources, maybe like in your data centers, and you have your Z system there, but you might also have other systems. You have set up a private cloud environment where you can easily create new resources in there, or you're even making use of public cloud environments, and that's all management of that. It's what we call IBM Hybrid Cloud. So in the management scope of the hybrid cloud here, I want to introduce some of the applications or utilities and solutions that help you managing that. I mean, this is only some, and especially I want to mention those because we have an integration with system automation with those. And later in this slide deck, I want to concentrate on that. But there are for sure many other applications, and so this is managing the hybrid cloud is not just what I'm showing here. But this is some pieces what I want to concentrate on in this presentation today. So first, let me start about talking about the Open Mainframe project, which is called Zoe. With Zoe, that's not an IBM offering. It's an open source offering that allows to work with the mainframe to allows with modern tools, so to speak, to interact with the with different mainframe products, middlewares, and so on, and let them to integrate into other and also state-of-the-art tools like managing tools, monitoring tools, and development tools especially. And here I want to talk a little bit about it. Then you might have heard about Ansible, and this is like from a solution which is also comes always into discussion when you talk about automation. Here, automation means more or less the automation of setting up your environments, of creating environments, creating your systems with the right set of installed software and configured software. So automation here means is bring me up a system and make it running in the level of code which I want to have, and start components, but also stop them if you want. And especially do it not only with one system, do it with many of systems which I defined. So if you have like a set of like hundreds of servers where you want to update the operating system and bring out the latest patch, then you can do that with Ansible. Same is true for if you want to update your web servers, your database servers, any kind of middleware, and even your own written software, and change the configuration, something like that. This is what Ansible helps you to do, and you will later see from me that we also have an inclusion here that Ansible now can be used to manage the z/OS mainframe, but in particular also can be used to interact with the system automation in certain scenarios. Next, there is something what you might have heard about is the Apache Kafka, which is like a kind of message broker system, and it allows you to get information from various subsystems that they send message status information to that Kafka to different topics. You can get those messages there and do whatever you want. You can either write your own dashboard solution to show the messages. You can consume messages and combine them with other information and make your own kind of reports out of it. So here, Apache Kafka, we have an integration with that, and I will show you that as well. And one thing I want to mention here is also Kubernetes, which is more and more under the discussion of and also like from IBM, because there are certain announcements that had been made and will be made in future to interact with Kubernetes, which is yet another management solution to manage the distribution and the starting and stopping of containerized workload in form of in Kubernetes they are called pods. So as said, those are 4 different solutions. Not all, but that's more or less the area where I'm currently working on, and with our team in Böbling we are working on, and that's what I want to talk today about. Okay, now let me first introduce a little bit about those who might haven't heard about C system automation, which is like an automation product available since many decades already on the mainframe, and being used as a premier solution for automatic startup and shutdown of components of resources, as we call them, and also to monitor their current run state and react on failures and messages mentioned by those applications. This is the system automation, and I want to start very from the beginning here. What is like the core of the system automation is that we are running, especially as you see here in the green boxes, we are running as a NetView application. NetView is another application which comes bundled together with system automation. That is more or less, for us the bedrock to work inside, for having the possibility to monitor and interact with those subsystems on the mainframe. And here there is one major component running on top of NetView is called the SysOps components, and then we have below, not below, we have the other component that is ProcOps. And last but not least, we have the configuration dialog. So what the components are doing is, so sysops is especially done the component that makes or provides service to monitor and control the operating system and the applications running on it. ProxOps is more like for the hardware operations. So it is possible to interact with the mainframe and to start to reconfigure the hardware to enable more processor speeds and extra processors or less processors to grow and shrink here. So this is all more on a hardware base, whereas SysOps is more on the software base, the automation. Yeah, and last but not least, the component is the configuration dialog, which I want to mention. Is the configuration dialog is actually a TSO ISPF application that is being used to define the so-called policy for us that defines again like all the components to be automated, how they are being started, how they are being stopped, how they are being monitored if they are alive, and what to do when one of those components issues a message on the system console and how to act on that. That's all stored in our policy, which is being defined by that TSO ISPF application, saved in the data set and activated later in the SysOps. And yeah, so that's all actually, those are the core components of the system automation as they are existing since many, many years. And now let's me continue what we did in the last years now to enhance on those components. First addition to that was one process which we call the end-to-end adapter process that allowed us to add modern dashboard UI. It's a web UI on top of it that people are not forced to log into NetView and use the 3270 commands to interact with system automation. They can use the SMU web dashboard. The end-to-end adapter has been developed, I would say, around like even already 15 years ago or even more. And it is a Java process that runs on the mainframe and allows the SMU web dashboard to interact using the HTTP protocol. However, the protocol between the web dashboard and system automation through that end-to-end adapter is kind of closed protocol. We do not reveal it to outside. So it is just being used by SMU, and that's it. So coming from that statement I last gave, we introduced like some years ago, I think 3 years ago, an SA operations REST API. And this is now really what it says, you're used to many applications outside nowadays. They have APIs and they have REST APIs. So the RESTful protocol is a kind of like standardized way to interact with software components. So this kind of protocol now we also provide and make it a description for that. So there is all the endpoints that have been made available with the SA Operations REST API are now described in a kind of Swagger description. And now you can use that REST API to interact with system automation, to query the current status of defined resources, of managed resources, to manage them in the way to start and stop them, and also you can interact with system automation with the main components like with the agents and with the managers, and also activate another policy and stuff like that. So this is all now possible with the Operations REST API. So I would say like many, not all, but many features which are also possible to interact with system automation using the NetView commands can now be done with that REST API. Okay, what else did we add? We add like in a recent release of System Automation 4.3, we added the SA Info Broker, which, and that's what I already explained a little bit before. that sends messages now to Kafka. And especially like when you know system automation, you might have heard about some component which is called the System Display Facility, SDF, which allows to, on the 3270 devices to show a table and a colorful table of the states of all components. And the information that is being used by SDF is now being also pushed to Kafka as informations. And any information, any message you want from NetView to send to Kafka, you can use, you can set up here and send it there. And one component that makes use of this new feature is the web dashboard, the SMU. However, since Kafka is your Kafka and you can create any application as you want to make use of those information. So we haven't heard about a customer yet using this, but what we wanted to have an open and as a kind of standardized way, not only to interact with system automation with through that REST API, but also to be able to see what's going on and sending those messages to Kafka. What also has been added last release is the so-called SA policy service provider. In the current release, it is possible to go to the policies saved in the data set, and and they are saved there in either in the data set in a binary format or before in some ISBF tables. And both is not really handy to work with and to do kind of like reporting, see what have you defined or whatever. This is only being seeable with the configuration dialog. However, also this is nothing really to easily to be exported and being used in some kind of other reporting. So with the policy service provider, we now have the possibility to export the policies into a kind of JSON document. And with this JSON document, it's quite easy to integrate into reports, into some DevOps tools or development tools, and see JSON and work with that and also get information what you have defined to automate. The SA policy service provider is like a component that will certainly grow in future. And one thing is also that it is a first step. Also to modernization of the configuration dialog. Currently, it allows this one service to to convert the configuration, the policy from ISBF tables to JSON documents. Okay, so now I want to talk about what does in nowadays world of DevOps, or where you have development for applications and operations of the systems, and hybrid cloud, how we work here and what challenges we have. So I want to introduce here some personas. First, there's the Eric persona, which is an application developer. And he's responsible to create new apps, and he's responsible to develop solutions for his company. For example, a new solution to calculate the plan for some insurance company, or to calculate a new product and stuff like that. So he develops applications. So far, he is the person responsible using and using his environment, his development environment. He saves his code into some GitHub. He uses Jenkins, Maven, or whatever to build the code. And after he has done that, then his work so far in a traditional environment is done. He releases the application, and from now on, it's time to take over for the management, for the operating folks to install the application and to run it. And actually that's other persona, second Mike. And typically in the traditional environment, they work in a different department. They are system programmers, and they're being called, okay, Eric has developed a new application, please roll it out. And that's their work, currently decoupled between development and operations. So the task from Zach and Mike is to ensure the availability of that application. First of all, install it, get it running, and keep it running. And the goal is to provide this in a stable way that it's there 24/7. So now what tools are they using, Zach and Mike? They are using, those are the users, traditional users of the system automation itself. So they use these SysOps components to interact with and to define the new application from Eric to the policy, and then they activate that policy, or they say, okay, the new application is there, a new version, please restart that resource, and so on. Yeah, and also they're using ProcOps in order to ensure that enough resources are being available in order to run that workload that Eric is developing. So this is a kind of traditional way to work with the system. You have the developer in the development department who develops and tests and releases code. And you have Zach and Mike in the operating department who install and get stuff running. So how in the DevOps world, how this comes together. So as said, yeah, you have two distinct groups of people, and you want to bring them together and now you see that's maybe you have seen that already, the loop in the DevOps environment. So that means that all three of them, and in reality there are much more than three, have to take care for and understand the work of the others. So Eric's job is not done when the code is done and released, but he also has to take care that stuff is running actually, because only then it makes money for its company. So Eric, Zach, and Mike all have to together to understand what's the code about, what is the configuration about, and also make sure that it's running in case of some problem occurs and some issues are being written and reported by customers. So that's all what is being also very often being referred to as shifting left, the responsibilities that especially the development folks get also a knowledge about when they test a pre-prod and they even going to production and see what's going on with the application and help them if some problem exists. Okay, so this like a side explanation. So in this kind of hybrid cloud environment and in a DevOps environment, now how can you use those applications to work? Let me first start with like Eric and how he does the application development and how the Zoe mainframe project can help in here. So first I want to introduce here for the development. There is like also available by that Zoe product, there is a plugin available for the Visual Studio Code. So once you install that, you can see that plugin in your famous editor IDE, and can actually work with Rex code, with PL1 code, COBOL code, and but also Java code together in one development environment. Eric does not have to change and work with ISPF dialogues or other tools to work. He is used to like the traditional languages like RexX and PLX, which can be used in and he has a kind of like syntax highlighting as well as he used to modern languages, and can work with the stuff. He has an outline of the modules shown in being used in Rex, and he can simply like he is also used in other modern languages, jump to the definitions of functions and features that are being included. That's all now possible with the IDE that Eric knows to also to use for development of other application components in, for example, Java, JavaScript, C, C++, or whatever. So the other thing what I want to mention is that Eric also likes to use is another plugin from Zoe, which is the Explorer extension for FTP. Here he also installed that in his Visual Studio Code, and then he is now able directly from his code, and where he sees like build outputs also and source code build outputs and stuff like that. And then now he can even copy it over to his test system, to his development systems from within this dialog. So he has the possibility to interact and see the data sets on the mainframe, but also with Unix system services, file systems like ZFS file systems. And last but not least, also he can work with jobs and issue them from here. You can see the status of jobs and stuff like that. So he is not forced to change his already known development environment to interact with applications on running on mainframe, whether it be the to work with configuration files and or also like see if they are running and what is the status of jobs and stuff like that. So this is like what helps Eric with development. Here you see an example of how you can issue and also edit your JCL within that Visual Studio Code and directly then run it from there. Now, one thing after Eric has developed his code, he wants to bring it to the mainframe. And there he knows about system automation is used to start and stop and automate this application that he developed. So one thing, this was in the past always a very clumsy project task to do. After development, he had to talk with the, he has to do a change request, and that goes to the administrators, and they had to change the policy, and then there is a change window required to activate the policy and stuff like that. So what we have added here in the already some reasons ago is a kind of construct we call dynamic resources. So in system automation policy, there is a set of pre-approved templates of resources. So that means whenever we have some application coming there, which is somehow still already known in other environments, Eric can just say, okay, here is a new version, and I please now automate it as well, and make a so-called dynamic resource from that template. So that's sweet. So what was in past? He developed the application, he transferred the application, configured it. Yeah, but then it is on the mainframe. He might even already use the CFTP plugin or something like that, but that's it. And now the traditional way he had to ask care for this application to bring it to production, to start and stop it. Yeah, and actually what they is they make even use of those template approach and call that command, which was in system automation called ingdin, and then the application finally was running. So, but anyway, Eric had to talk with Michael Zek to do this for him. So what is now the new way with an SA plugin for the Zoe CLI? You will learn about this in the next slides also. The development is the same. He does the development also with the plugin in Visual Studio Code. But now with the plugin, which is also available by Zoe, he's now able would issue some command directly from his to simply now automate his application that he has been pushed. So there's actually no real need anymore to create a change request and then talk with admins and operators. As long Eric is using templates which have been pre-approved by the policy developer, he can do that by his own. Now let me talk what is the SA Ansible role doing for people like Mike and Zach. So Mike and Zach is there in order to take care for the environment, for the mainframe together. They have to ensure that the configuration is always consistent and up to date and reflects to what their company wants. So and they would like to do it everywhere in the same and repeatable way, and so they are making use of Galaxy. They're making use of Ansible, and they're making use of shipped collections available on Ansible Galaxy, freely available, so you can simply download. Two collections I want to mention here. The one is the IBM ZOS Core collection for sure, that allows Mike to interact with ZOS systems like the same way he interacts with Ansible and with Linux system or Unix systems. And especially he is able to ensure with that collection that certain values are being set in configuration files in the ZFS or in data sets. Yeah, and also, and that's what we bring into that story is the collection called IBM ZOS SysAuto. With that collection, Mike is also able to work with system automation, and not only that, he's able now to do like basic interaction with the ZOS mainframe, and even there are much more collections available on Ansible, also for like standard solutions like AIMS, Geeks, and DB2. But he now can use yet another collection called IBM ZOS SysAuto, especially, and here what it does with the IBM Z System Automation SysAuto collection, he now can do those stuff like creating, deleting dynamic resources once it's needed. So he can also do it with Ansible. So how is Ansible achieving that? Yeah, making use of that REST API, which will have been added here. And and the way Ansible works is like you always have one particular system that's called the Ansible management node, from which you do all your work distributed on all the systems. And that's by executing so-called playbooks, which are like documents describing the goal, what you want to achieve. So you tell Ansible, okay, here's my playbook, that's what you want to have. And Ansible goes out and says, okay, I want to do that now on different systems, target systems. And here now, especially those target systems can be ZOS and can be automated by the system automation that's possible with Ansible. So what you did with some commands and also what could be done with Zoe now can be done in a bigger context of setting up systems and ensuring that everything is running in the right way with help of Ansible. Okay, so here's like actually what you see when you start Ansible on your control node and execute it by hand. So you will get like an output to standard out, and it's being shown that Ansible goes out and finds the systems, takes care, gets connection to the system with SSH, and finds out the current situation on those systems, what's running and stuff like that. And especially here, like with the system automation, it will make sure that what is being wanted, that those templates are existing and resources are being then created, dynamic resources at request of that book. So what you see here is first an output that those resources are not existing yet. And after the playbook has been executed, a new resource had been created. And the EAP TST2 application, which is, as you see, it's a dynamic resource because it has been created by a template, is now available after this playbook has been executed. So you don't have to remember the commands. You don't have to use manually the Zoe command on like hundreds of systems in order to roll it out. But you can use Ansible to run playbook, and Ansible will ensure that the goal that you expressed in the playbook is being ensured and being set up on those systems where you want it. Here's one example, a little bit more complex example, how you can combine now those different collections. Here's one example combining the IMS collection together with our Z System Automation collection. So first, like if you want to a special IMS subsystem to be provisioned on your mainframe, you can use that collection and say, okay, first get me the service that you want and provision it. And in the next step, now go to system automation, also automate it. That's all done by Ansible by a declarative way of describing in the playbook the different steps that you, or the target actually, not how to do it, but what you want to describe it, what you want, and then Ansible will roll it out and does not run it only on one system, but on all systems that you run the target, the playbook against. Now let me talk a little bit about what we did with Kafka. As I already explained, we introduced the SA Info Broker that has a main idea in the first use case to replace that already 3270 and therefore aging interface of SDF and have that those information also available on the dashboard on SPOO. So therefore, we developed the SA Info Broker, which sends messages from so-called producers to consumers. And the first use case we had here for this was we wanted to change to send SDF records to something like an SDF tree in SMU. So what is Kafka? Kafka actually is a message broker which is organized by topics of and in topics you have like data of a specific area be collected, and you always have like some producers to send the information into topics and some consumers to get those information. So and that's actually basic concept of Kafka, but having a topic in which information messages are being sent by producers and consumers use them. And Kafka makes sure that everything what a producer sends to that topic is really received and being even replicated to different services. So it's never being lost, those information. Kafka is highly available and redundant by itself. And also Kafka ensures that messages are immutable in their sequence they're being issued. So a consumer will never ever get messages like a later message before the message before, so that the sequence is immutable, so that they can also make use of like when they get multiple messages from, for example, from one resources, but status of resource, they can make sure, or they can be ensured that the last messages contain the current status of that resource. So that's actually what Kafka all does. And again, so Kafka producer consumer. Then there are other concepts like connectors and stream processors. So producer, you've seen that like system automation with the so-called SA Info Broker is one producer, and another consumer is the SMU. But for connectors and stream processors, there are possible ways to use information and combine them with other information, maybe in a database that has been maybe written by some other kind of monitoring solution. And last but not least, you can define so-called stream processors, which take the information and enhance. So every message sent to that topic is then going through the stream processor, being pre-processed in the way that there can also be enhanced. So if you get like some error message, then the stream processor can take the error message and find already a solution, something like that, and write it back together to that error message and put it back to Kafka, so that the consumer not only get the error message, but also get maybe already some hint to solve it. So that's all possible in the area of Kafka. And also because of this mightiness of different solutions and scenarios, we chose, instead of writing yet another proprietary protocol to send events, we chose to send the information to Kafka. And we hope that helps in future to easily to make use of those messages and consume them differently. But now let me come back to the Zoe and talk a little bit more about this one. So as I already explained before, Zoe is the open source software framework. And in the first LTS version, it only consists of the 4 blue shown major components. LTS stands for long-term support version. So it's the application framework itself. The mediation, so application framework itself can be seen as the kind of like an appliance where you open and then have a web interface to interact with your mainframe. Then there's the Zoe mediation layer that is like a dictionary of REST interfaces on that system available. So and make it easy for you to consume all those different APIs, maybe from system automation, from NetView, from IMS, from DB2, from whoever, all has already APIs to make available there with the mediation layer in Zoe. You only have one telephone book to see all those APIs, and you also have the chance to configure it that you only have to authenticate against one time against the mediation layer that you can use all this API. Then there's a command line interface. You already seen a little bit of it, and you see more in the coming slides. And last but not least, there's the Zoe Explorer. There was a Zoe Explorer in order that it gives you like on Windows a kind of explorer to work with data sets and partition data sets, sequential data sets, the same way as you used to work with other file systems. Yeah, just click on it in a folder, see what's inside, and then open it, edit it, and stuff like that. In LTS version 2, which is out since half a year now, there have been some new components. Especially, I want to highlight here the Zoe chat component, and also give like a little outlook because system automation is also integrated with that. The other one is actually the client SDK is something in order to help better to enhance the Zoe core framework with new features. And and the rest you might, if you're interested, I have to point you to the Zoe documentation more or less to see what those incubators can help to do you. As said, Zoe is part of the Open Mainframe project, and thus it's not part of IBM. It is IBM plays a big role and contributes lots of code into that Zoe project, but it's open source. Here you see some slides about Zoe, what is the application framework. So as you see here, you see a kind of like similar to any dashboard solution or to any appliance when you have like some appliance or what you have, it's opening a kind of desktop, and inside the desktop you have the possibility to interact with that one mainframe and even open in a built-in file explorer and editor some of those files and data sets and work with them. So that's the application framework. The mediation layer, as said, is a kind of like dictionary that helps you to look up all the REST APIs available on that server. And you only have to authenticate once against that REST mediation layer, and then you can use any of that API. And the API from system automation is also being listed here. Then there's one component from Zoe, that's the Zoe command line interface. That's the component that everybody has to install on his laptop once he decides to use it. So the Zoe command line interface is written in Node.js. So you have to install Node.js or on your laptop. So that's available on to interact with different solutions on the mainframe. And last but not least, you have like the Zoe Explorer. You've seen like Eric using that. It is a plugin into Visual Studio Code that allows you to interact either with data sets and even also with the job entry subsystem to see the current status of jobs and execute them. And you also have like a kind of like very nice feature to like syntax highlighting and direct jump to other included modules and stuff like that. So this is all done with the Zoe Explorer. And one thing I want to mention, because I think this is kind of cool and unique to our solution here, is the Zoe Chat solution. And here you are able now to use a kind of social media tool. I would say like MS Teams or Slack or MetaMouse, in order not only to interact with your colleagues in the DevOps team or your company, but also to directly interact with like the mainframe by talking to some kind of bot. So in the channel, then you're talking to your fellow, to your neighbor, to your colleague, maybe about some problem that currently has been issued by some customer, and or some message that has been seen on the mainframe or any other system. But now you can in the chat directly talk with system automation and or with IMS or Megaman and get me the status, and then it's being the bot in Zoe Chat will go out and ask this information and push it in the chat channel, that everybody who is in the channel where you're doing the chat instantly sees what's going on. So you're not forced to switch your attention to a different application to get the current status and then verbally again go back to the chat window and tell about it to the people in that channel, but they see the information directly in the channel. So interaction with your system becomes the same on the same level. Then you do the interaction with people in that channel. Okay, so that's about Zoe Chat. Now let me CLI is a laptop as plugin, and yeah, although possible on the mainframe yet, you just want to play with that, fine, you can install system automation, for example, configure the rest, you have to configure it started, and then you can directly go into your Zoe CLI and point it to that REST API and interact with system automation. That's possible. The work you see here in the picture again, the Zoe CLI plugin, system automation also is active with the operations first. Here, a slide showing you how to get that plugin. So there are two ways to get the plugin. One way is you simply install Zoe, which is basically free, and then you got it as Android with like those @ Zoe. You will find it there and simply install it. Or first you go to the Zoe web page, which will point you there, and you install it then on your laptop. And yeah, in the plugin, they the system automation, and then this and directly reach out to Maximo, and install is done. And now you have to set up a configuration to your server, and then you can interact with system automation. What I also mention here is there is a Zoe conformance program that issues some kind of conformance badges. And we can say that for the SA plugin, we have reached the conformance to the LTS version 2 version of the Zoe plugin. So we are state of the art actually with the plugin, and LTS v2 is the current working long-time support version of Zoe.
Hi, you see, sorry to butt in, but I think you're cutting out a bit.
Okay, so now everything starts by typing in Zoe in your command prompt, and then you choose a plugin. Here there are many plugins, and some plugins are already built in when you installed it. So like ZOS Console Files and Jobs is actually using the same technology that you've seen by me. Connect directly to the console and see what's going on, what messages are being received, work with files and also with jobs on JAS. But there are also like some plugins possible to install additionally. It's like one plugin for NetView, and like that plugin that we provide is a system automation plugin. So for the system automation plugin, you know what you do. Next is you choose your action want. You want to either activate, create. Yeah, that's the verb, what you want. And then you choose the object that's against all your resources. Then you say Zoe SA list resources, that is, or the short version LSRES. And then you see that. Same is good for like for the other actions. And yeah, you see, especially I want to here, since this was a request from many customers. Now with the plugin as a plugin is also.
Yossi, we're losing you.
Able to activate policies. So you do not activate which system you want to. So this is those option parameters, depending on what you chose before, an action object, the option parameters are different, can then be added. So this is in general how all Zoe commands work. So here's an example, like how you would list the resources of the type, all resources of type application, which are currently being not online. They are observed soft down. Yeah, and then you type it in. So you say LSRES, type APL, observed soft down, and then you see a table like similar on your laptop, like you would also get when you type in a similar command, ing list in NetView. So what else is possible, like with the Zoe CLI plugin? Here are some examples how you know get more information about one specific resource. Here's what happens when you do it and get an error, because here in this example, the resource row test 1 is existing multiple times in that Sysplex managed by system automation. So it is not identified and uniquely identifiable. You get an error. So then, because row test 1 is existing multiple times on the Sysplex, you have to specify the type and also on which system of that you really want to see it, and type it in. And then you get more information about this one resource, actually. Some of you might know, and then you might already use to the command in NetView where you say ing list, and then this is much easier to use. And don't worry, it's also possible in system automation and in the Zoe CLI plugin. You can, what we have, it's also a convenient way. You can say name of resource slash type slash system. You can also use stars everywhere, and then you get the same result. So here is one example, like about how a policy is being refreshed. So you type in Zoe as a activate policy, and here in this case, I just want to refresh the current policy. So I want to reactivate it. The current policy, that's quite easy, and the next step to do. if you want to see like if a policy has been activated, or if you want to see the some more information about the automation manager, so you say Zoe as a view member role as a primary automation manager, and then you get all those information. Why is that always playing? And you get the information about the primary automation manager, which is one component of the system automation. And that helps you, for example, to see what is the current configuration being loaded, but also much more information, what kind of communication groups is running, what is the current status, if it's running, since when it's running, and so on. All those kind of information is now not only available through the traditional NetView interfaces, not only available by using maybe REST API, but also by using the Zoe plugin for the CLI. Okay, here is like a way that shows you how to stop the resource. You say, yes, the resource name. And okay, I will continue here because I just look at the watch. So one thing I want to mention also, if you have the Zoe readable friendly output, but it's also if you ever want to use the Zoe CLI to do your own programming, your own shell scripting, then you want some JSON output, for example, and then you do it by a built-in flag to the Zoe CLI. This is --RFJ response format JSON. So you get everything not human readable, but you get a complete JSON, and then you can use your JSON parser as you want to later use information and for example, use it and write your own command to combine it with some other information. So that you are really keen to write in your own bash command. This is only a coding example to list all groups. You can write it in bash and you say Zoe command here and with --RFJ at the end. So this will then return all the groups and display, and then you can display them as you want. I mean, this is actually more get it human friendly, but maybe you want it differently and you want to combine it with some other information and calling the REST interface and using a higher level language, or you can use always the Zoe as like a CLI traditionally to include it into other programs. Okay, now I'm over and I'm also more or less at the end of the hour. So it took me to more time than I expected to
Happens to everyone.
talk about the environments and ways to interact with the mainframe system automation.
Okay, so
using newer tools. Always to me and can give some feedback. So I'm happy to get those feedback, and I'm also there for any kind of questions. Name that was I've very nice resting and many good nice sessions to come, and see you next time.